Okay, now using the program that we wrote so far, if we listen for incoming connections in Kali and then come here and run the program, you'll see that first of all, it's going to send connection established using the send method. And now it's waiting for me to write something, and whatever I'm going to write is going to be sent to the Windows machine, which will be printed on their terminal. For example, if I use a Windows command, for example, ipconfig, you'll see that this will be sent and this will be printed on the Windows terminal because I am printing the result that is being received from the receive function. Now, instead of printing this string, I can just pass it to subprocess.call, and then this string will be executed as a system command. Now, we already spoke about subprocess and how it can be used to execute system commands on any system, and we actually had a look on a number of methods such as call and check output. Now, call will allow us to execute a system command, but check output is more useful because it's going to return the output to a variable so that we can send the result back to the Kali machine where we'll be able to see the result of the command that we sent. And thus, we'll be able to establish something similar to this where the hacker is going to be able to send system commands and receive the result and see it on their screen. So, we're actually going to be using functions that we've seen before. So the first thing that we'll do is import subprocess, which is a library that we had a look on before and we know exactly how it works. Then I'm going to implement a function and I'm going to call this function execute system command. And this function is going to take a command as a string. And what's going to do is it's going to do subprocess dot check output, and it's going to execute my command. And since this command is going to be a string, not a list, we're going to have to set shell to true. Now, we spoke about all of this before, that's why I'm not spending too much time about it. And then, instead of call and print in here, I'm going to call my execute system command, and I'm going to pass the received data to it. Now, the subprocess.check output returns the result of the executed command. So we can either capture this in a variable here, or we can just return it so that the execute system command function will return the result of the command that it gets. And then I'll be able to capture this in here, and let's call this command result. And since the received data is going to be a system command, I'm going to rename this variable to command, and I'm going to rename this variable here to command as well. Now let's have a look on what we've done so far. First of all, we're going to create a socket object, then we're going to connect to our target, then we're going to send a message saying connection established. This will be printed on the terminal on the Kali machine. Then we're going to wait for the person on the Kali machine to send us data. This data is going to be stored in a variable called command. Then this variable is going to be passed to a function called execute system command. This function is going to use the variable that it's going to get, the command variable, and it's going to pass it to subprocess.check output, which will execute this command, and then it's going to return the result after execution. Now, my function is also going to return this result to the line where it was called from, and that's going to be captured in my command result. And finally, once we actually receive this result, we're going to send it. So we're going to add another line. We're going to say connection.send, and we're going to send my command result. So let's go and test this. I'm going to listen for incoming connections, run my program. As you can see, the first thing that we get is connection established, and everything pauses waiting for me to enter a command. So right now, again, like I said before, we are at this line. The system is waiting for me to enter some data, and this data will be stored in the command variable. So let's put a command, and let's put a dir command, which will basically list the contents of the current working directory. And as you can see, this command got executed and we received the result as well. So basically what happened is, command now is equal to dir got passed to my execute system command. Execute system command called subprocess.checkOutput with the command that is dir. The result was returned from this function. It's captured in the command result, and then it's sent back to the Kali machine by doing connection.send, and we're sending the command result. And the result, as you can see, we're able to first of all send a system command and receive its result. Now, if you think of it, and if you look at the code that we used so far, we actually did not use and did not introduce anything new in this lecture. Everything that we used is something that we knew before. We were already able to establish a connection. We were already able to send and receive data. All we had to do is just think of the data as normal strings. Forget about all the boundaries that you might tell yourself that this is not going to work and this is not right. And all we had to do is first of all receive a text, execute the test using a library that we already knew, and then receive the result, which is a normal string, and send it back to our target. And the result is a working backdoor that is able to execute system commands on the target computer. So it's something similar to this. The only problem is we're able to send only one command and receive only one result. Ultimately, we want to be able to execute as many system commands as we want and receive the results of all of these commands. Now, doing this is very easy. Again, using things that we already know. We know that these 3 lines of codes are what's sending and receiving the commands for us. So we can wrap all of this in a while loop. So we can say while true, I want to execute all of this. Now, we spoke about while true before. Basically, a while loop is just a normal loop, and we're setting the condition to true. So this loop will be executed infinitely. The first thing that it's going to do, it's going to wait. So it's going to pause the program and wait for a command. The result will be stored in the command. It will be passed to my execute system command. The result of that is going to be captured in the command result. And then all of this will be sent back to the machine that we're connected to. And we'll do this infinitely. So let's go on the Linux machine, listen for incoming connections. And in here, I'm going to connect. And as you can see, the first thing that we get is connection established. Let's run a system command like dir. Now, as you can see, we received the result of our command, but the program didn't exit. So if you remember before, once we received the result, the program terminated. Right now, the program is still running. So right now, we went through a full iteration over this loop, and we're back at this line, and the program has paused, waiting for another command. So now I can send another command. For example, let's say ipconfig. Again, this will execute all the code in the loop, returning the result of the command that I just executed. And again, it's pausing at this line, waiting for me to enter another command. So, for example, I can check my privileges by doing who am I? And as you can see, I'm getting the result of that command, and I can continue executing system commands, which are Windows commands, for as long as I want to. And now we actually have a good backdoor that you can actually use in a real life scenario. It'll spawn a reverse connection to you, so it's less suspicious than a lot of backdoors. It's manually written by you, so it'll be detected by less antivirus, if any. And you can use it to execute system commands, and it's going to work on Windows, OS X, and Linux. And basically, using the system commands, you're able to do everything that the normal user can do. Now, this is not the end of this. We're actually going to improve this in the next lectures and add more useful features to it.